Narbacular Drop is the game that got Valve to make Portal. It was made by a team of students for their senior project. The story goes that right after they presented the game to Valve, they were all offered jobs on the spot. They were then right away assigned to a new project, and that's how we ended up with Portal. But Narbacular Drop is ancient history by now, and even back then it didn't have a thriving modding scene, so would you believe me if I told you that I spent a week of my life descending down a rabbit hole and writing entirely new tools just to backport Portal 2 maps to Narbacular Drop? Okay, first of all, how did we get here? This game doesn't have much in terms of modding tools. It's a showcase at best, there's no remaining community around it, so what inspired me to do this? Well, I randomly found out that one of the tools I use for modding Portal 2 supports reading the package format of Narbacular Drop. That's it. That's the whole inspiration, and from there I asked myself, could I mod this to be like Portal 2? Of course, it wasn't going to be all that simple. This tool could only read the file tree, but not write to it or even parse the model data. And taking a deeper look, it's obvious why. The file format is actually incredibly simple. You could even piece it together with a hex editor if you had the patience. So I'm guessing that the authors of the tool just threw it together one day, just for fun, as it wouldn't have taken long to do. But if I was going to actually mod the game, I needed a way to at least swap its assets somehow. I first thought I might be able to do some rudimentary texture swaps by finding the offsets pointing to the bitmap files and shifting everything manually. But I'm glad I caught myself before jumping at the first idea that came into my head. Notice how the root file tree contains 3 directories: levels, audio, and video. The textures are all in the video directory, but something seemed familiar about the levels folder. You see, for level building, this game uses a program that converts special Gold Source era hammer maps into the game's proprietary format. In the tutorial for this tool, you're told to place any custom maps under levels/polishingup.cmf next to the game's executable. But here, in the game's package file, we can find a file for the same path, levels/polishingup.cmf. This suggests that the game first checks for files outside of the package and only then loads the packaged versions. And the theory was that if this works the same for all other assets, there may be no need to reverse engineer the package format. By now, I had already rebuilt a part of Test Chamber 4 with the extremely limited built-in assets. And just to test if the texture override theory works, I impatiently slapped a few pictures of a Portal 2 storage cube onto the crate bitmap, loaded into my Smooth Jazz remake, and there it was, an Aperture Science storage cube time-traveled to before it was invented. Naturally, now that I had a foot in the door, going from this to texturing everything else was a matter of simply doing more of the same. What bugged me was that I couldn't figure out a way to replace the models of entities, as those too seem to use a format I didn't recognize. And I wasn't gonna reverse engineer compiled 3D model binaries. We'll come back to this later, I promise, but for now, this only really mattered for the buttons. Given that the cubes were now Portal themed, I really wanted to make the floor buttons match and look more like the big red ones from Portal. For this, I came up with a simple but effective solution. Use the level editor to cover the white and boring button entity with a non-solid floor shaped like a button. This actually worked surprisingly well. It kind of fits in with the overall low-tech vibe, and, of course, most importantly, nothing important broke. Holding down the button still opens the door. Speaking of which, I spent a good hour trying to figure out how to make doors work before giving up and simply assuming that they're broken. And I later found out that I was right. The standard door entity was cut from the game during development. Instead, the level exits all use a special door entity that loads the next level. These are very limiting. You can't resize them, you can't rotate them, they always face south, and once they're open, you can't close them either. And I forgot to mention this at first, but you can only have one of these per level. If you place in more than one, it just won't work. But, you know, for a simple level like this, it's passable. Now, at this point, it could have all been over. I was satisfied with what I had made, I learned a few things along the way. That's an evening well spent. But, of course, I just had to come up with something else. The idea of making a tool that automatically converts puzzles made in the Portal 2 level editor to Narbacular Drop maps was way too exciting to sleep on. Literally, the following night I stayed up until 5 in the morning writing a prototype for this program, and once that was done, all I could think about in the coming days were ways to improve it. The reason this is even possible is that, well, remember how I said that the Narbacular Drop levels are converted from maps generated with an old version of Hammer? Well, those map files that Hammer produces are very similar to a modern-day VMF. That's the format used for compiling maps in games like Portal 2. All it took to create something that resembles the shape of a test chamber was to move some numbers around. Of course, the hard part was going to be reproducing actual puzzles. Sure, I can get the walls to look similar, but these are still two completely separate game engines. I can't just tell Narbacular Drop to connect a button to a door, because not only does it apparently not understand what a door is, its entities also just function completely differently from those Portal 2 uses. At the very least, I was going to have to build a sort of translation layer between the two languages. And I was gonna have to find ways to substitute missing entities. Most of the puzzle elements from Portal 2 obviously have no equivalent in this glorified tech demo. Right away, I got to work porting over the simpler entities, those being cubes and simple lights. These are just single points in 3D space with no additional logic, and after that came buttons and doors. These obviously do have some map logic attached to them, and for now, to simplify things, I just made all buttons in the level point to a single counter entity, which then points to the only door I can afford to have in the level. Of course, you'll notice that these buttons are still the small crappy white ones. To solve that, I made a very simple map in Hammer containing only that button-shaped floor I mentioned earlier, and had my code effectively copy-paste that on top of each button. Now the only problem is that the physical button is smaller than it looks, so to remedy that, I placed 4 of the small buttons at each corner of the big one, and linked them all together to create one big super colliding super button. At this point, you could technically build an entire Portal 2 test chamber for Narbacular Drop. So that's what I did. Introducing the first ever Narbacular Drop puzzle designed entirely within the Portal 2 in-game level editor. Of course, it's really nothing special. Currently, all you can make are simple cube and button-based puzzles, and maybe something with flings if you get creative. We'll get to porting the other testing elements in a bit, but for now, I wanted to tackle a few more pressing matters. I still wanted to figure out how to swap out the models, because I felt like that would make it 10 times more immersive. From a quick search, it turns out that these .x files are actually DirectX models. These have been long abandoned in favor of more modern and flexible formats, which is probably why I've never heard of them before. Of course, Blender doesn't natively support them, so I had to install a couple of plugins. But even these are dated and kept throwing errors in specific cases. I managed to import the Narbacular Drop cube model as a reference for scaling the Portal 2 cube, and after hours and hours of debugging textures, I finally got it to load. There it is. It felt like I had unlocked a new chapter or something, as I had now proven that it's possible to change the models too. And now the issue was that the buttons were way too low poly. They stood out like a sore thumb, but armed with the experience of working with DirectX model files, I could swap out those too. When I loaded up the original button model, it was split into 2 separate objects. I assumed that this was so that they could animate independently, which is why I made my button also consist of 2 separate objects. I will later go on to discover that this was absolutely pointless, but oh well. The scale of the button in Blender was also completely off, so I couldn't use it as a reference. I had to eyeball it, but after just a couple of retakes, I ended up getting it exactly right. And to once again counter that issue where the buttons look bigger than they really are, this time I just made the cube model smaller. The reasoning for this is that the hitbox of the cube doesn't depend on the model, instead using its size property from the map file. So if I made the hitbox bigger but the cube model smaller, things will look the same as before but with much more reasonable collisions. Now the game had this borderline uncanny feel to it, like something isn't quite where you expect it to be. Needless to say, the chambers were starting to look pretty good, so next up on the list was making them more functional. To start, I opened up the list of testing elements in the editor, and, well, it didn't look too promising. I can't implement most of these, simply because Narbacular Drop doesn't have an equivalent for things like lasers, turrets, or even moving walls as previously discussed. So I took the opposite approach. I went looking for interesting behavior that could somehow be useful for Portal 2 testing elements. And while messing around in the so-called art room, I noticed that landing on the stationary boulder would sometimes shoot you away with a ton of speed. And it just so happens that there's a testing element that does exactly that, the aerial faithplate. And there you go, I had my new mechanic. All that was left was to figure out how exactly the launching thing works. Okay, so normally a boulder rolls along an axis-aligned path with a set speed, crushing the player if they get in the way. When creating a map, you can set the speed of the boulder as well as the direction that it rolls in. With a bit of tinkering, I found that setting the speed to -1 reproduces that effect of it rolling in place, but touching the boulder still crushes the player sometimes, even if it's not moving. And I think the way this works is that it checks for a player in the direction that it's supposed to be rolling in, even if it's not actually rolling. To work around all of that, I buried the boulder in the ground where the faithplate would normally be, and made the rolling direction point directly downwards. And since you can only ever reach the boulder from the top, it won't crush you, but will fling you like expected. Oh, and making it point downwards also has the added benefit of disabling the rolling animation, which means that, just like before, I can swap out the boulder's model for a model of the Portal 2 faithplate. This was admittedly easier said than done. The faithplate model uses a reflective glass texture for its surface, and to no one's surprise, Narbacular Drop doesn't have a glass shader. I had to edit the model to remove the glass while making it still look like a faithplate at a glance. In the end though, this was all completely worth it. The faithplate works better than I expected, and although you can't control the direction it launches you in, it still gets you a good amount of height for clearing gaps or setting up flings. So far, we've been spending a lot of time looking at the puzzle maker, but in theory, there's nothing stopping me from converting campaign maps with this. It's the same file format, but the texture and entity mappings are quite a bit different. My initial test of Smooth Jazz looks significantly worse than the handmade version. This is for a few reasons. First, a bunch of the textures are missing. Second, there are no lights yet. And third, there are many more props here left unaccounted for. It doesn't feel like you're walking through a Portal test chamber. It's more like an empty shell of something you barely recognize. There's also another, less visual discrepancy. Remember how I said that the first prototype algorithm was hastily thrown together at 5 AM? Well, now that's finally coming back to haunt me. Every wall is considered one whole solid. That's the simplest way to program this, but it's also not entirely accurate. Take, for example, this extrusion here. Currently, the algorithm treats it all as one large portable block, and that's fine in most cases. But watch what happens if I color half the surfaces black while leaving the others white. Since this is all still one big block, all faces share the same surface properties, and the algorithm now has to make a choice. Do you make the whole thing portable, or do you make it all non-portable? And regardless of what you choose, it's still going to be wrong. You need per face surface properties, and the only way to do that in Narbacular Drop is to create one solid per face. In a nutshell, that's what the new algorithm does in most cases. There are still some scenarios where it still defaults back to the old system, but that's besides the point. Really, all of this is besides the point, because while this is an important issue, and while there's still a lot of work to be done in this regard, I'm kind of just avoiding the bigger problem. We need more textures. Or, specifically, I can see two paths forward. For one, I could just improve the mapping for my existing limited library of built-in texture overrides, or two, I could write a program that extracts textures from Portal 2 and converts them into a format that works in Narbacular Drop. Can you guess which one I chose? Well, that was a day of my life that I'm never getting back, but dare I say, the results were kinda worth it. Yes, without an actual puzzle, it still feels like the shell of a test chamber, but at least the shell now has a pretty coat of paint. Needless to say, this completely solves the texturing issue. I also had the script extract surface properties for each material, so I could automatically flag them as portable or see-through, without needing to manually go over every texture. From here, I kept improving the entity translation, working on small compiler bugs, cleaning out the code, optimizing and structuring things, and once I was ready to get back to working on functionality, I lost all motivation in the project. Instantly. See, I picked this particular map as the test dummy for a multitude of reasons. It's an incredibly simple puzzle, consisting of just cubes and buttons, and it's one of the rare few that has 2 chambers in one. In the first part, a button links directly to a door, while in the second part, it's 2 buttons using a counter as an intermediary. It's a perfect testing ground for simple entity connections. Except I don't have anything to connect to. I don't have doors. And okay, how hard could it be to stitch together a door, I hear you ask? And that's exactly what I thought, but it's not that simple, turns out. When you think about it, a door is just an obstacle that can be removed arbitrarily. And there are plenty of obstacles in Narbacular Drop, just none that you can get rid of from a button press. For example, you could construct a door by putting a boulder in a small room with an opening. As it rolls back and forth, the player can't proceed until the boulder is gone. You could shoot a portal to get rid of the boulder, effectively opening the door, and that could be a tiny puzzle on its own. But there's no interface for moving or deleting boulders from map logic. In fact, here's a truly exhaustive list of everything you can do by triggering outputs. You can make text appear on screen, you can restart the level, you can open the level transition door, which I'll remind you is very limiting and I can only have 1 per map anyway, and you can make lava rise. That last part, by the way, is exactly what it sounds like. You can make an arbitrary pool of lava slowly go up, but not down, by 32 units each time it's triggered. At first I thought, that's it. You could just put a block of lava in front of the door and then trigger it to rise up and out of the way. But that's not what happens. The lava doesn't go up, it stretches up, so the bottom of it still kills you. Then I thought I might be able to do something with the level reset input. Technically, if you put a trigger plane inside of the door and connected it to respawn the player once touched, you would have an obstacle. Connect the trigger through a counter linked to a button, and you'd have an obstacle that turns on when you hold down the button, which seems so close to a valid solution, but it's literally the opposite of what we want. What I needed now was a logic element that the game just doesn't have, a NOT gate, which effectively flips the input it's given. I tried a bunch of stuff to implement this, even making the tolerance of buttons negative, and that almost worked. They remained pressed down without a cube, but I couldn't figure out a way to unpress the button, even if I made the weight of the cube negative too. I had already given up and started writing the script for this video when I got it. I figured it out. All of the puzzle pieces moved into place. I knew exactly what to do. Okay, some of this is gonna sound insane, but bear with me. Narbacular Drop has these creatures called lava turtles. They float on lava to escort the player, but stay in place when on dry land. And crucially, the turtles can hold down buttons. So if you place down a button, then a turtle on top of that button holding it down, and lava right below the button, you can now trigger the lava to rise, floating the turtle off of the button. Connect your input to the lava and your output from the button, and boom, that's a very mechanical NOT gate. And this is how that mechanism looks in-game. The only downside is that, because of how slow the lava is, it takes a while for the turtle to float off the button. But otherwise, I can just create as many of these as I want out of bounds, and suddenly I've invented a new logic element. As you can imagine, this brought back enough interest in the project for me to tie up the loose ends. I ended up actually implementing doors. Well, really, they're more like slightly scuffed laser grids. They take a while to turn off because of the lava rising, and visually they always appear on, which is why I added on-screen text to indicate when it's safe to pass through. And since you can't make the turtle's lava go down in any way, the laser grid will also remain disabled once it is triggered. This would mean that just stepping on a button once permanently solves most chambers. So to fix that, I made it so that the laser grid only turns off if you're next to the exit while the door is being triggered. And finally, to prevent the player from just shooting a portal past the grid, I used a wall with only one solid side, which not only blocks portal shot traces, but also works as a one-way gate to simulate the door closing behind the player. Of course, I also went back and added support for laser grids to the Puzzle Maker suite. And as for doors, well, there's no way to create more than one exit door in the level editor anyway, so for that, I could just afford to use the level transition door. Though if you're gonna be making chambers with this, just remember that this type of door cannot be rotated. Oh, yeah, by the way, you can set this up for yourself. Well, sort of. this isn't a consumer-grade application. There's no fancy UI with buttons and menus. It's a command line tool, and it's all written for Linux, so it might not even work out of the box on your system. If you're still interested in trying it out, or in digging through the commit history, you can check out the GitHub repository linked in the description. But don't ask me for help setting it up. You're on your own. I have better things to do than to spend my evening explaining to strangers how to install WSL. You will need to own a copy of Portal 2 to extract the textures and models from, both for moral and legal reasons. And of course, you'll need to supply your own maps. If you want, you can also skip extracting the assets and just use the built-in Narbacular Drop textures. Here's what that looks like on Smooth Jazz. You know, I'd say it actually looks kinda cool this way too. Anyway, this project was on the very outskirts of my comfort zone, I guess. I might keep working on it in my free time. There's still a lot that can be done, but my line of work typically revolves around programming mods for Portal 2. So if that's something you're interested in, you can check out my other videos or commission a mod on my Ko-fi, link in the description. It's a great way to support what I do, and you get something cool and playable in return. Okay, that's all from me. Subscribe if you liked it, and I'll see you around.